Okay, we're here with Ankur Desai, and we've been talking a little bit about interdisciplinary work and multidisciplinary work and the challenges of it. And I guess the first thing I'd like to know is how you got into this line of business in meteorological research.
It's very interesting, and in many ways I fell into the research that I did because I've always been interested in environmental and earth system sciences, and I've also had an interest in weather. And it was through my training, partly by having a interdisciplinary degree in environmental studies as an undergrad and going into a geography program, and then finally ending up in a meteorology program, that I've always had in my back of my mind the importance of kind of looking at the whole Earth system as we're understanding meteorology and atmospheric science. And in our panel today, we were discussing kind of the rewards of working with partners across disciplines in atmospheric sciences. As someone who works on biosphere-atmosphere interaction, I decided to give a talk about how to talk to an ecologist, because as somebody who plays both an ecologist and a meteorologist, there's a lot of messages we can learn. We ignore biology and meteorology at our own peril. The advances that we've been learned in global ecology and microbiology and so forth over the past few decades have dramatic implications for how we understand the climate system and the weather system. And so that's kind of where that was the message I was trying to portray today.
Now, what are some of the biggest challenges you faced, like in your own work with bark beetles and their effect on the ecology?
Well, a lot of this, and that's a great question, a lot of this goes to understanding the fact that biological systems, ecological systems have a dramatic variation driven by natural selection. It's very place-based. What's occurring in one spot may not necessarily have a lot to do with what's occurring in another space. There's a lot of complexity in the system, and it doesn't necessarily have universal physical principles that we currently understand or know. Whereas in the atmospheric sciences, we have nice things like the conservation of mass that work for us, and we can use and apply just about everywhere and get a good answer. So a lot of challenges often are just trying to understand how those two mesh and the scales at which we can understand each. And what I spend a lot of my time doing is at meetings, sitting down with ecologists or folks in natural resources or environmental sciences, and just getting our language correct, just getting to the same starting line before we can even continue on our research. For example, working with understanding why is there large-scale mortality from bark beetle mass attack into western North America? How is that related to climate? How is that related to biological interactions between bugs and trees? It's very complicated.
Is ecological science more statistical than, say, meteorological work, or?
I would certainly say yes, from a kind of cursory overview. If you've had an ecology grad student over here and an atmospheric science grad student here, the atmospheric scientist speaks in differential equations and can understand that language very well, and the ecologist is scared of that. And the ecologist is an expert on statistics at a level that the meteorologist would generally have less of a background. And part of this goes back to the physical principles that drive a lot of biological interactions are not as well constrained. So that's, from that perspective, yeah, the statistical level of thinking in ecology is generally higher. That said, I think we're seeing a convergence in both fields, and that statistics has become a very fundamental part of what we do in understanding meteorological and climate systems. And at the same time, mechanistic modeling and process-based modeling has become a fundamental part of what we do in ecology. And one of my goals in my research is really to kind of mesh that together.
We see a lot of biological aspects to meteorological work, even here at the annual meeting.
Right.
We're seeing land surface schemes and climatological considerations, for global climate that come from the biogenic aerosols and stuff. So the intersection is there. Would you say that we're prepared to deal with that intersection through education and training?
I think we are. I think we're starting to see that biology and ecology are becoming becoming into the curriculum, into the research. My graduate students work regularly on both sides of that coin, thinking from an ecological perspective on the ground, in the field, making a measurement that's biologically related, as well as working back at the meteorological level, looking at measurements of atmospheric state and variability. I think we're getting there. As I mentioned in my talk, one of the issues we have often in a meeting like AMS is really bringing that biological, those people who work in ecology into a meeting like this. We often, for example, agriculture and Forest Meteorology. Specialty conference never meets at the annual meeting, so we don't interact so much with the climate variability folks. We don't even interact all that much with the hydrology folks. The new AMS Board on Atmospheric Biogeosciences, of which I've been one of the founding members, it has a mission partly to kind of infuse biogeoscience across the American Geological Society. And I think under the chairmanship of Elizabeth Petit, that's kind of where we're headed.
Thanks a lot, and good luck with the board.
Thank you.